Hello everyone, myself Nidhi Chopra, Assistant Professor in Physics from Khalsa College for Women Sidhwan Khurd, and today I am going to deliver a lecture on GM counter. Gas fill detectors we have already discussed in our previous lecture, so today we will do some extension. The basic principle of the GM counter is that when the charged particles enter the gas chamber, then it ionizes the gas present in it, as a result of which electrons and positive ions are produced. These initial ions produced get accelerated because of the high potential applied on the electrodes and get collected at their respective electrodes after doing secondary ionization. And thus we get a current pulse. Next is the construction of the GM counter. For this, we require a cylindrical chamber which is generally made up of a metal, and sometimes we use a sealed glass tube of radius 2 to 3 cm which is enclosing a coaxial metallic cylinder, and the walls of this metallic cylinder act as cathode. Second thing is the thin metal wire. We use a thin metal wire which is stretched along the axis of the cylindrical chamber, which act as anode, means a positive potential is applied at this wire. The free end of the anode is covered with a glass bead to avoid corona discharge building up at the sharp points. Third thing is the thin window made up of mica or any other material, provided for counting less penetrating radiations like alpha or beta rays. Fourth thing is the inert gas. The gas which we are using in the cylindrical chamber is inert, like argon, helium. In this case, we are using argon along with ethyl alcohol. Ethyl alcohol helps in quenching. Now, what is quenching? We will discuss it later in the working of the GM counter. So, the two gases are present in the ratio of 10:1, where 10 parts are of the argon and 1 part is of the ethyl alcohol. In some counters, neon gas is mixed with traces of halogen, and halogen are famously used as quenching vapor. The gases must be free from electronegative impurities such as CO2O2, which have the tendency to form negative ions and initiate secondary avalanche. This is the schematic diagram for the GM counter, where you can see the cathode as the cylindrical vessel, and inside it we are having gases, the atoms of the gases. Blue dots are representing the electrons. Anode is of the red color, the thin wire at the center of the metallic chamber, and the yellowish curvy waves gives us the incident radiation. So when the charged particles or the ions are collected at their respective electrodes, then we get a current pulse and the counter counts. Now we will discuss its working in more detail. So when an ionizing particle passes through the gas in the GM tube, ionization takes place, means electrons and positive ions are formed. The electrons produced get attracted towards the central wire, as it is provided a positive potential and counted as a single voltage pulse. The wire anode is surrounded by slow moving positive ion cloud, which in turn reduces the electric field. As a result of the decreased electric field, the discharge stops, means the collection of the electrons at the anode wire stops because of the presence of the positive ions around that wire, the central wire, which restricts the path for the movement of the electron towards anode. The discharge continues to stop till the positive ions around the wire are completely removed. Now, since the positive ions are very much heavy, so they take enough time to get away from the anode and move towards the cathode. So during this time, the GM counter is dead. That's why this time is called as the dead time, during which the counter fails to record any of the ionizing particle entering the counter. Positive ions move away from the anode towards the cathode, and the value of the electric field increases and another discharge takes place. It is essential that the electric discharge caused by the ionizing particle is completely quenched before the arrival of the new particle. Now, in order to remove these positive ions from the anode side to the cathode side, we use different techniques for this. So here comes the topic of quenching. Quenching means eliminating of the positive ion cloud around the central wire so that it makes a path for the electrons to reach the anode and thus gives us the current pulse and the count. So there are different methods for this. First is the external quenching, which uses external load resistance in series with the tube, means external circuits are used for this quenching method. Second is the internal quenching, in which gases are used in the gas chamber, just like the ethyl alcohol which we are using along with the argon. Here the ethyl alcohol is acting as a quenching gas. So gases can be of any type, polyatomic or halogen, but mainly halogens are very much preferred as the quenching gases because of their property that after dissociation they get back to their original state. We will discuss each of its working in detail now. First is the active quenching, also called as the electronic quenching and external quenching. So in such type of quenching, the electronic quenching uses simplistic high-speed control electronics to remove and reapply the high voltage between the electrodes for a fixed time after each discharge peak to increase the maximum count rate and tube's lifetime. The second thing is the self-quenching, also called as internal quenching. In case of a self-quenching, the quenching gas, means the ethyl alcohol we are using here, have a weak affinity for the electrons as compared to the argon gas. Therefore, ionized atoms of the argon gas readily take the electrons from the quenching gas, means ethyl alcohol gas molecules, and thus neutralize. Thus, the ionized molecules of the quenching gas, means the ethyl alcohol gas, reach the chamber wall, means the positive ions of the ethyl alcohol reach the chamber walls and instead of the chamber gas, means instead of the argon gas, the ethyl alcohol reaches the cathode. The ionized molecule of the ethyl alcohol are neutralized by gaining electron and energy is liberated, does not cause further ionization, means does not produces secondary ion pairs, but this energy is used in dissociation of this ethyl alcohol molecule. So thus we do not get any secondary ionization due to the cathode side and we get accurate results. This type of quenching is known as self-quenching and internal quenching, since tubes stop the discharge without any external assistance. In case of halogens, we get them back after dissociation after some time. That's why halogens are mainly preferred for quenching process, for internal quenching. Now we will discuss about the advantages and disadvantages of GM counter. Advantages are that these counters are very useful for detecting nuclear particles like alpha, beta, photons and charged particles. They are very sensitive even for a single ion pair production. The pulse height in these cases is independent of the nature and energy of the incident radiation. And the fourth thing is height of the pulse is almost constant over a wide range of applied voltage. Now, we will discuss about its disadvantages. So these detectors are having low efficiency of counting gamma rays. Second is these detectors lack any information related to the incident radiation, means which type of incident radiation is coming, it doesn't tell us about that. Third is detector cannot detect uncharged particles like neutrons. And fourth thing is GM tube has limited life because of the quenching gases. So here our topic is complete of the GM counter. Thank you. Have a nice day.